Okay, on the circuit training, the first question says, find a limit equation for the integral 0 to 4 of x squared plus 1 dx. Okay, find a limit equal to. So, you know that this means you need a limit with a sum. So you always know, or you should know, that it starts with the limit as n goes to infinity of the sum of k equals 1 to n. Doesn't matter whether it's k or j or whatever, just use it consistently. All right, now, the rest you're going to have to figure out little by little. So here we go. Step 1, figure out delta x. So delta x comes from the 4 and the 0. So delta x is equal to 4 minus 0 over the number of rectangles. So delta x is equal to 4 over n. So that means you're going to have a 4 over n outside on over here on the outside. We always also use the delta x inside the x term, but we'll keep going from there. Okay, so number 2 is figure out what a is. Now, a is always the lower bound, so a equals 0. Our inside function, the a plus delta xk, then for this would be 0 plus 4 over nk, or just 4 over nk. So this is what you were going to replace x with. So you would come up here and do the square root. Oh, no, I was looking at the answer one. We don't have a square root. You have a squared term. So this would be 4 over nk quantity squared plus 1. And then that times 4 over n. So I just moved that a little closer instead of putting it over there. Now, that's not multiplied out, so let's multiply it out. So I'm going to say it's the limit as n goes to infinity of k equals 1 to n of 4 squared, which is 16, over n squared and k squared, plus 1 times 4 over n. So there's your answer. So this was number 1, so go look for your answer that is number 2. So I think it's on, I'll just tell you what page it's on. It's on the second page, bottom right. Okay, so I think if we were numbering 1, 2, 3, 4, 5, 6, 7, it would be number 8. So we'll go on to number 8. Right, so we found number 2. There's the answer we got for number 1. This says find the limit to go from 0 to pi over 2 of cosine 2x dx. So again, you start with the limit as n goes to infinity of the sum of k equals 1 to n. So it's going to be that. And now we'll do delta x. That's my 1. I'd figure out delta x would be pi over 2 minus 0. So that would be over n. So pi over 2 and over n. So I'll just say pi over 2n. Okay, so now I know that a is equal to 0. So my x of k would be a plus, I'll write it here till you get used to it, a plus delta xk. A is 0, so 0 plus delta x is pi over 2nk. So this is what we put inside our function. So we get cosine of 2 times pi over 2nk. And then times delta x, which is pi over 2n. And so we're just going to cross that out. So our final answer should be the limit as n goes to infinity of the sum of k equals 1 to n of cosine pi over nk times pi over 2n. All right, so that should be your answer to number 2, and go find number 3. So number 3 wants a limit equal to this. So we would say the limit as n goes to infinity of the sum of k equals 1 to n. So let's look what we have from 3 to 7. So we have 4 over 2n, no, 4 over n as delta x. But this time a is not 0, a is 3. So when we write our middle, this is number 1, this is number 2. When we write our middle, a plus delta xk, it's 3 plus 4 over n times k. And that has to go up inside that. So it's the square root, I'm just writing it down here first, 4 times 3 plus 4 over n k minus 3. And so I'm going to multiply this out. This would be the square root of 12 plus 16 over nk minus 3, which is this and this can combine. So 16 over nk plus 9. So that's what I'm going to write up here, the square root of 16 over nk plus 9 times delta x, don't forget that, which is times 4 over n. So that's the number 3, how you do number 3. Number 4, let's make sure I did that right. You got k, 1 to 16 over 1, k plus 9. Okay, so that's right. So going on to number 4. I'm going to actually stop the video and start with number 4 in the next one, so the video is not so long.